over to Andre and Alcio, and then they can send it over to you guys. So
okay. Great. So whoever has missed the opportunity, they can watch it afterwards. Wonderful.
Right. Yeah.
So I'm a business developer here at NeoScan, which is a new company founded by Alexander Sessov, and it's located in Belgium. So we don't have the pretty climate that Brazil has, but we do have wonderful fries and beers and chocolate. So it's a great opportunity to come and visit whenever you're in Europe. Here at NeoScan, we focus on the design and the production of scientific instruments for X-ray microtomography, also MicroCT or X-ray microscopy. So the technology, you will see it by many names. To those of you who are new to MicroCT, I would like to start with a short introduction about the technology. So what is MicroCT? In MicroCT, we use an X-ray source which will emit X-rays. We have a sample which can either transmit these X-rays or partially absorb them. And the remaining part of the X-rays, which will have the capability to go through the sample, that is what will be detected by the X-ray detector. As such, this setup seems very similar to radiography, something you might know from hospital when you end up there with a broken bone, or the security checkpoints at the airport. However, in MicroCT, the main difference is that we use it for 3D imaging. And how we do that is by mounting the sample on a rotation stage. So instead of taking just one of such images, we will actually rotate the sample in small steps. And in this way, hundreds or even thousands of such images are acquired at every angle, which can then all be reconstructed to a three-dimensional data set. So here on the left-hand side, you see such a projection image, which gives you two-dimensional information. In MicroCT, hundreds of these projection images are then needed to reconstruct a full cross-section through the sample. And the one you see here in the middle is one such cross-section positioned at the green line which you see on the projection image. So if you were to virtually cut the sample, this is the view that you would see inside. The sample that we're looking at here in this example is a geological sample. It's a cylindrical carbonate stone of 8 millimeters diameter. Now, in MicroCT, we don't just get one image, but we get an entire stack of such cross-sections. And, oh, I see the bandwidth is struggling a little bit. Yeah, that's a pity. Let's try it again. Okay, so in total, all of these slices can then be rendered to a 3D visualization. Now, a few important keywords to remember about MicroCT. So MicroCT provides non-destructive imaging. It's non-destructive because we work with X-rays, and X-rays just travel through the samples. You don't need to cut the sample to be able to see inside the sample. MicroCT provides microstructural information. So the information that we get out of a CT dataset tells you something about the structure of the sample. So if you look at the cross-section here in the middle, you see bright areas and you see darker areas, and these relate to the capability of a material to absorb X-rays. So bright parts are materials which absorb a lot of X-rays. Dark parts are materials or areas which absorb less X-rays. And of course, the black, that would be where we have no X-ray absorption, or let's say the air. We also introduced the word microstructural. Yeah, so micro is a very important word here because we're looking at information on a micrometer scale. Even when in literature or in the market, you would be looking at NanoCT, remember that in X-ray microscopy, the word nano applies to everything that is below 1 micron. So this means that although people are really trying to push the resolution limit of such systems, what they can actually see is in the range of several hundreds of microns. Yeah, several hundreds of nanometers. So it's not a technology suitable for nanoparticles or such. And of course, sorry, yeah, let's move this out of the way. And of course, every information that you get applies to 3 dimensions. So I hope to all of you who are new to the MicroCT technology that this short explanation has excited you as much as me and all the people that I met and trained in these 12 years that I've been in the business. It's just fascinating and fun to work with MicroCT, but probably it also triggered some questions. And the questions which usually pop up in a first discussion about MicroCT are the following. What details can I see in my samples? What size can I scan? And what material can I scan? And often these 3 questions, they relate to 3 parameters, let's say, which all define altogether define the system performance and very often also the price. So the details that you can see relates to resolution, and also sample size and voltage have an important effect on the choice of instruments. Now, of course, if you want the best of all 3, so you want the highest resolution and the highest voltage that you can get, and you want to be able to go up to large sample sizes as well. If you want the best of all 3, then typically you'll be looking at huge systems. Huge systems, unfortunately, also come with huge budgets. And here at NeoScan, we use our experience and our knowledge and our latest and also the latest innovation to bring systems to the market, which are a very sweet deal. The NeoScan systems all have a superior performance to price ratio, and they offer amazing image quality with a great ease of use. And that's what I would like to talk about today. So our portfolio currently has 3 systems. From left to right, you see that there is an increase in the number, so N60, N70, and N80. Now, it's not only the number of the model which increases, you also see this arrow in the background. Yeah. Also the size increases, but even more important, the specs or the performance of the system increases, and unfortunately also the price that comes with it. Now, it's these specifications or the performance of these instruments that I would like to talk about. Yeah, and these specs that you see here all relate to the questions which you probably had when hearing about MicroCT. So let me explain. First, you see the first one of the questions was, what material can I scan? So the atomic number of the material set or density of the material determines how much energy you need to have in your X-ray source to have the capability to travel through the sample. Yeah, and that defines, you see, for N60, we can go up to 65 kV, for N70 up to 100 kV, and for N80 up to 110 kV. So the higher the kV, the more types of materials you can scan inside the system. The second 2 lines relate to nominal and spatial resolution. Both these parameters would answer the questions, what details can I see? Now, there's 2 different lines, and in both lines you see that as you move from left to right, the number gets better and better. Yeah. Particularly the 2 micron spatial resolution in the N80 is something which has never been done before in a benchtop system. Okay, so let me take 1 minute to talk to you in detail about resolution. So maybe let's start from the basics. In MicroCT, we often speak about voxel size. Now, a voxel is by definition a pixel in 3D. We're working with a stack of images, and every image has a thickness of the size of the voxel, the pixel. Yeah, that's how it becomes a voxel. Then in MicroCT, people often speak about the nominal resolution. Now, the nominal resolution is basically the smallest pixel size that one can potentially achieve in a system. Whatever this value is depends on the scanner geometry and also the geometrical magnification. This is expressed as M, and it's a ratio of the distance between the object and the source, and the object, the source and the detector, this one. So, of course, one could think the further away I put my detector, the larger this distance becomes. So SD will increase and also my magnification will increase. So I can end up with high magnification for the camera pixels, and I end up with very small pixel sizes. Very correct. However, making a large system and bringing the camera all the way to the back is not the only thing you need to do to have a high resolution. There's other things involved in resolution of a MicroCT. Remember, the question you're trying to answer is, what can I see in my sample? And for that, one needs to look at the spatial resolution of a scanner. Now, spatial resolution is a slightly more complex topic, but let me bring it down to the very basics that spatial resolution is a combination of the pixel size and the spot size in the source. So spot size is, let's say, a measure of the sharpness of the spot, the size of the spot where the X-rays have been generated. And important to understand is that this spatial resolution is something that can be actually measured. It is defined by resolution charts in 2D or in 3D, which you can actually place inside the system. You can do the scan, and in the image, you can actually prove what is the actual spatial resolution of your instrument, what you can actually see and resolve in your data set. Yeah. It is important to remember that spatial resolution defines ultimately what can be seen in an image, and that all NeoScan systems have a superb spatial resolution. Now, just for completeness, I would like to mention that when talking about resolution in MicroCT, you might also run across the topics of the MTF, which is the modulation transfer function, and detail detectability. But let's not make it too complicated or technical today. So let's move on to the final question that we had. What sample size can I scan? Yeah. So here you see a list of, or for each instrument, you see the size of the object that you can put inside the scanner. And also here you see the smaller scanner, and 60 can accommodate smaller samples, but and 70 and 80 are equipped with large sample chambers. So basically, we would say anything that fits inside the scanner can be scanned, because it's important that the door can close. After all, we are working with ionizing radiation. Okay. Now, before we will be looking at each instrument separately, there's something I want to explain to all of you. As you could see from the previous images, all of our instruments are benchtop scanners, and there are a few important benefits which I would like to address, because the importance should not be underestimated. While many manufacturers make huge laboratory instruments, we really see the benefits of a benchtop scanner, and we hope you see it too. Benchtop scanners come with a very small footprint. It means they will fit in any lab. They are easy to transport, and they can be placed on any standard table. Much better than having to work with concrete floors or special elevators for installation. You don't need any extra space for compressors or chillers or whatever you need on larger systems. Also, our benchtop scanners have a very easy installation. All of them fit through a standard door. So you don't need any double door. Yeah. They all only require a standard wall socket, so no high voltage power generator is required, and we would call it plug and scan. The instrument arrives, you take it out of the box, you put it on the table, you plug it in, and you start scanning. That's how easy the installation of a benchtop scanner can be. And thirdly, benchtop scanners are equipped with a sealed X-ray tube. Now, I could speak for more than 1 hour only about the benefits of sealed X-ray tubes, but let's focus, or let's try and bring it down to a few bullet points. Sealed X-ray tubes offer the benefit that they are maintenance-free. There is no compressor which requires maintenance, etc. Also, there are no filaments inside the X-ray source which have to be replaced. For these two reasons, sealed X-ray tubes also offer a very low cost of ownership. And this means also that there is a very little downtime of the system. You can just run it 24/7. You don't have to turn off the system to replace any filaments. And finally, of course, very important to understand that sealed X-ray tubes don't only apply to the benefits just mentioned, but they also provide a very high ease of use. So you don't need a high education of the operator to use the scanner, as opposed to open X-ray tubes. Now, before moving on to the individual systems one by one, I would like to mention that all our systems come with our in-house developed software package, which provides scanning, reconstruction, and visualization. Everything is integrated into one software package with a very easy operation. It comes with a graphical user interface, which is just like a Microsoft Office style. Yeah, it has different tabs here, which follow the workflow of a MicroCT scan. So for scanning, reconstruction, and visualization, where you have big icons for the basic operations and more smaller icons which relate to the more advanced settings for advanced users. All our software is license-free. You can install an unlimited number of copies to as many computers as you want. You don't need an internet connection to activate anything, and the software updates are free and time unlimited. Whatever we make in terms of innovation or improvement to our software, we make it available to all our customers. Several copies of the software can also run simultaneously, and the data that comes out of the software is in formats which is compatible to all commonly used software for analysis of the MicroCT scans. Some known products, both basic as well as advanced, would be Volume Graphics, Aviso, Geodict, Simpleware, Dragonfly, and many other available in the market. Our systems all come with remote diagnostics, especially having experienced a pandemic, as we all have. I think this is a very important tool to have. So remotely we can log into the system, and it's more advanced than just doing a TeamViewer session. It's actually a test program that we can run remotely, and it will give all the voltages and the power supply units, the temperatures in different parts, and all the information that we need to instantly diagnose whatever might be potentially wrong in the case of an unexpected event. This means intervention can be done free of charge because we don't need to travel, and it can also be done a lot faster, which means that ultimately you have less downtime of your system. There's also a few accessories that we have made. These are available on the N70 and N80 scanners, so the two bigger ones. Yeah, we have an automatic sample changer, and this is outside of the shielded area. So while one sample is inside the scanner, you can fill up this carousel and replace them with new samples to be scanned. We have 24 positions available, and this really allows you to generate a high throughput of your scanner. We also have devices for in situ scanning. So, for example, we have a thermal stage, which can provide heating and cooling to a certain sample. The temperature will be from -40 up to 120 degrees. So this can be used for any freezing, cooling experiment, as well as anything above boiling temperature of water, let's say. And then the third accessory I would like to propose to you is a compression and tension stage. So this accessory, where here you see a geological sample installed inside the in situ stage, allows to compress or pull, perform a tensile experiment. In this case, we are going to compress a geological sample, and the maximum force that we currently have available in our range of accessories is 1000 Newton for both compression as well as tension experiments. Okay, good. Now, moving back to applications in MicroCT. So now we understand a little bit about instruments and how they work, how the technology works. So what do people want to do with a MicroCT data set? So you put something in the scanner. Okay, great. Now you get a 3D volume out of it. So what do you do with that volume? Well, people will either be interested in visualization, and then typically what they will be looking at, or what you might be looking for, are internal defects. Yeah. Most often people will be interested in quantifications. So a pretty picture of the inside alone is not good enough. If you want to publish something, of course, you need numbers. What kind of numbers would you like? Well, we would categorize it into different segments. Some users focus on doing density measurements. And this is an application we mainly see with bone researchers. And I would say the majority of MicroCT users would focus on morphometry. And this would refer to all kinds of numerical measurements, let's say. So you want to get a number for the porosity inside your sample, the volume of particles inside the sample, how they are distributed, where the biggest one is located, how they are connected, and all kind of numbers that you can think of. And then a third category would be referring to 3D modeling. Now that you've done a 3D scan of your sample, you can extract an STL model out of that data, which you can then use either for input to do flow simulations, or you can use that model to evaluate where your 3D printing processes can improve, or you can use the STL model itself to generate a 3D print of your sample. Okay, now again, here we have our three instruments. So let's first have a quick look at the N60. So this is our compact benchtop MicroCT, and with a maximum voltage of 65 kV and a spatial resolution of 8 micron, it offers a quite good alternative for people who are not looking at the highest density range of equipment. So why would you choose an N60? First of all, it's a very compact and accessible MicroCT. It only has a weight of 45 kilograms, and nevertheless, we don't make any compromises on the image quality and the lifetime of the system. Let's have a look at some examples of what you could do with an N60. There we go. So an N60 can be used for pharmaceutical samples like tablets, dental samples, some small tooths. In geology, we can scan carbonates, and a lot of food applications run perfectly on the N60 as well. And we even try to push the limits of the system by scanning a USB 3 flash drive successfully. One application I would like to explore in detail with you today is an application in bone research. Now, many people who are currently using MicroCT in bone, they use either a 5 micron or an 8 micron MicroCT scanner. And in fact, our N60 matches that performance. So it also provides an 8 micron spatial resolution. And as you can see here, that is sufficient to scan a mouse bone. Yeah. So don't underestimate the capabilities of resolution, but also transmission. People might think 65 kV is a bit limited, but here we've scanned a 12mm vertebra without any artifacts visible in the image. And if you're not convinced yet, I would also like to show you the actual cross sections through these bones so that you can see that these images come out at very high quality. So depending on your application, the N60 might be just the perfect match for your application and your budget. Okay, next system I would like to briefly touch upon is our N70. The N70 is a more general purpose benchtop MicroCT because it offers a 100 kV X-ray source. So naturally, more dense materials would also fit inside the scanner. Not only dense, but also larger samples. And the resolution becomes better. We're now moving to 5 micron spatial resolution, and the smallest pixel size would be 2.5 micron in this system. So why would anybody choose an N70? Because it offers the ultimate performance to price ratio. It has a high resolution, it can provide fast scans, so it really opens the door for high throughput applications. Think about scanning hundreds of bone samples for your studies or hundreds of tooth samples for dental research applications or 3D prints in industry. All of that is possible with our N70. All of that is done with high image quality, and of course our systems, or all of them, are targeted towards a long lifetime. And that is because all our systems have radiation protected image sensors, which is something we have noticed in the past, that a common defect in MicroCT scanners is the fact that image sensors get damaged by the X-ray radiation inside the scanner. That's why all our NeoScan instruments use radiation-protected image sensors. So, some examples for the N70. Here we're looking at a scaffold. Let's move this out of the way. Here we're looking at a scaffold, a biomaterial. Let's turn it on. Let's see. Okay, the connection is problematic again. So here we were scanning a scaffold. It was a 6 millimeter sample, and this was scanned in less than half an hour for ultimate quality on the N70. And you see, a MicroCT dataset really gives you a virtual copy of what is going on inside that sample. You can really scroll through it and take a look inside. On the right-hand side, you see how 3 orthogonal views throughout the scaffold are looking. And if we look at high resolution, you can actually see how you can follow the scaffold all the way from the top of the scaffold to the bottom, or from the left to the right. You can calculate the local thickness of the struts. You can calculate the size of the pores, which has an effect on how the tissue can regenerate. Scaffolds are used for tissue regeneration, for implants. So it's important to get a good understanding of how easy accessible these structures are for the surrounding tissue, so that they can grow back very easily inside this scaffold. Yeah. Another interesting application for the N70 would be on 3D printing. Here we have an example of a 3D printed part, a polymer 3D printed part. This cylinder was about 1.5 to 2 centimeters. I don't remember the exact size. But you see, with the 3 orthogonal views here, if we zoom into this, you can see that you can actually, after the 3D printing, you can use MicroCT to take a look inside the sample and evaluate the quality of the 3D printing process. This is not only possible for polymers, but also for titanium samples, like in this one. Now, good for the customer, not so good for us. This was a print of high quality, so we couldn't detect any details in there. But please notice how the sample has an outer rim here, which you also see in this point here. So it looks like a normal cross, but here you have this thin ridge. Yeah, and if we look at that in high resolution, you can really see the quality with which we can inspect such samples. This was done at 4 micron pixel size. Okay, and then moving on to our N80, which is really our flagship of the portfolio. So our N80 has the highest resolution in the benchtop, going up to 110 kV, and a spatial resolution down to 2 micron. Our N80 is available with 2 different camera configurations. It can be supplied with a flat panel camera, which would mean the smallest pixel size would be 0.9, or you can choose to have an N80 with a CCD camera, which would mean the smallest pixel size would be 0.35. Yeah. Now it's application specific, which is the best camera. But again, let's just focus on the reasons why we should choose a NeoScan N80. Well, I already mentioned it, but the NeoScan N80 is really the highest resolution that you will find in a benchtop available in the market, because it uses a brand new, very unique X-ray source from Hamamatsu. It's a sealed transmission target X-ray source. On top of that, we guarantee the systems will have a very long lifetime, because this unique X-ray source also has a wonderful innovation in it, which means target repositioning. And also, again, our detectors all come with radiation protection. So long lifetime of the system, and of course also a very low cost of ownership. And the third reason to choose a NeoScan N80 is because our instrument really offers the highest image quality. All our customers confirm it. Whenever they see our demo results, they are impressed with the quality. And this is not a coincidence. We have implemented several things, such as active artifact suppression, which means that our images are free of ring artifacts. Not only in the, so many choices have been made, both in the choice of components, such as a symmetrical anode, but also in all the mechanics, the electronics, and even the software. I listed a few topics here, but let's not make it too technical today. People who are interested in this are always free to be in touch with us, and we'll be happy to explain the technical aspects of our N80. But let's show you what are potential applications for our N80. Well, here you see again a variety of examples. All of these examples can also be found on the website, should any of you have a particular match with one of these. Yeah, so we have some insects, glass fibers, carbonates, and bone sample, a shale sample, but even some high-dense applications, such as a smartwatch, which size is relatable to anyone, yeah, to show the performance of the 110 kV X-ray source. But today, I would like to show you the composites and the bone, because what is very unique about the N80 is the 2-micron spatial resolution. And compared to existing benchtop systems in the market, which have, similar to our N70, a 5-micron spatial resolution. Yeah. When you use a system with 2 micron spatial resolution, in fact, you end up with a system which has 15 times better resolution, because we're working in 3D. So you have to take it to the 3rd dimension. 15 times better resolution means that now with our N80, we can do applications. We can see things which previously was impossible to see in a benchtop. Previously, you had to go to a huge system like a NanoCT. Now, with NeoScan, with our N80, we bring that capability to the users with a benchtop MicroCT. So here we have one example of a carbon fiber. So it's quite large piece, but if you zoom in, you can see that you can actually visualize all the individual carbon fibers. So all the boundaries are easily detected, and even some the binder material around it. As a proof of the high image quality of our N80, I want to show you that not only the central part can be resolved at high resolution, but also the entire peripheral area can be reconstructed at high image quality. So all round shapes are round. There is no misalignment. There are no ring artifacts to be seen whatsoever. Another application I wanted to focus on was the bone research. Yeah, and up to now, all benchtop systems used in bone research were offering either a 5-micron or an 8-micron spatial resolution. Now, what can be done with a 2-micron spatial resolution? Now, we did some bone studies, and what we noticed is that N80 allows the visualization of osteocytes in this example, trabecular mouse bones. So we did a scan with a pixel size of 1 micron. The spatial resolution was 2 micron. And what we saw in the data was several closed pores. Yeah, so it's the blue dots that you see in this image. Now, typically these have a size which is too small to be seen with a 5 micron system consistently. But what we noticed was these are all closed pores. And now if we analyze them according to size, we end up with a size which is consistent with the size of what is known that osteocytes have. On top of that, it seems that this top corner here, which is mineralized cartilage, doesn't have any osteocytes, and all of this part here is the trabecular bone, and this part has osteocytes. Yeah. And this is also something that is already known from other technologies. And here it's been validated in another way. So using different visualization techniques, the trabecular bone having these osteocytes on the right-hand part and the mineralized cartilage where it is known that it doesn't contain osteocytes. That is the part that you see on the right. So we're super excited to explore many more applications in the upcoming years with our 2 micron resolution source. I would like to also show you an example of the benefit of the high energy that our N80 can supply. So N80 offers 110 kV in the X-ray source, which means that it makes it ideally suitable for dental applications, especially once you start looking at tooth with filling materials. So here you see an entire tooth which was scanned at a high resolution of 3 micron per pixel. This was done in only 1 hour. Yeah, and if you look at cross sections at different heights, so one here in the top where this is the root, yeah, with the dentin of the tooth, and on top here we have the enamel layer. So this would be the part that is visible in the mouth. Yeah. If we would make a cross section here along the green line, you can actually see these different densities. So this enamel layer and the dentin layer inside, which is of a lower density. And basically, what you see is that we have a very high image quality. There are no ring artifacts due to this active artifact suppression, and all these thin cracks and even density differences relating to mineralization or demineralization in dentin can all be seen in the image. But also, high energy is really beneficial when you start scanning filling materials in tooth, because these typically have a higher density in terms of X-rays than the actual dentin and enamel materials. So again, in this tooth, it was a molar tooth, so it's a bit bigger with an implant, and even then you can see the density difference inside the dentin material, a high image quality, which will reveal very small details, and the image is free of ring artifacts. Now, to conclude, I would like to show you one final example. It's an example from 3D printing as well. This is an example that can be found in biomaterials as well, where we actually did a comparison of the N70 with the 2 other systems, N80, really to see what added value can this resolution bring. Yeah, that the N80 has. So it's 15 times better resolution. What does this give us? And here in this example, you see on the left-hand side the mesh, which is 3D printed. We scanned it in the N70 with the pixel size of 2.5 micron, and the spatial resolution would then be 5 micron. Scan time was 20 to 60 minutes, depending on where we focus on speed or quality. Yeah, but you see that the N70 is capable of resolving all these fine layers. So you have thicker layers, which were more consistent, and then these thin struts here, they consist actually of a range of very thin layers. So with our 5 micron spot size, we can visualize all these individual layers, and we can really separate them, which is on the level of the high accuracy of this 3D printer. But when we move the sample to our N80 with a flat panel, all of a sudden you get 15 times more detail inside that same voxel. And on top of that, because the N80 has a transmission source, we can bring the sample closer to the source, which means we can achieve a higher pixel size. So with our N80, we managed to scan it at 1.25 with a spot size of 2 micron. Yeah, so this would be the spatial resolution. And here you can actually see not only the space between the different layers, but you can actually see that at one point inside that mesh, and actually this happened at a few points, you see that there seems to be an issue with the 3D printing. Yeah, and it seems the printer is struggling to get a nice and homogeneous layer. And it seems to be not only in this thin layer, but also in this layer. You see, every time in the same position, no matter which layer is being printed, but it's always in the same position that the printer is struggling. And this is information that is very clearly present in an N80, but that doesn't come out in the N70. So in summary, we have 3 benchtop scanners, our N60, which is our accessible model. We have an N70, which is the ultimate performance to price ratio. And we have our flagship N80, which offers the highest resolution in a benchtop MicroCT available. So I hope you found today's webinar informative. We talked a little bit about what is MicroCT. I hope I managed to explain the benefits of the NeoScan products to you. And we also had a look at some application examples of the typical instruments. If you have any questions, you can drop them in the Q&A box here, as Kelly explained, or after the webinar, you can always find us on LinkedIn or send us an email or go through the website to reach out to us. Thank you very much for your attention.
All right. Yeah. So just like you said, please just put them in contact and we will answer them for you. If we don't have any questions, we could, like Evie said, you can email NeoScan, or you can email Andre, or you can email me. I can put my email in the comment box. So I think we have.
I'm trying to find the chat window. Kelly, can you see if anybody asked?
Yes, I can read you the questions. So, hi Evie, very nice to see you. Again, working with MicroCT. This is Marco. You talked about free software for visualization and so on. Do you provide software for analysts as well?
Okay, hi Marco. Thank you for joining us. Great to see you again, although I'm not seeing you, you're seeing me. Thank you very much for joining us today. Unfortunately, no, analysis software is not included in the software which comes with our systems. So currently we only supply whatever is needed for the instrument. So the instrument quality, the acquisition, the high quality reconstruction, and afterwards visualization to evaluate if you really targeted the highest quality in the scan. For analysis, we always typically try to make a recommendation depending on the application, and we collaborate with third-party packages. Our data is also compatible, by the way, with all software which you are currently using at the moment as well.
Okay. All right, and then we have 2 questions from Greg. We have, are there many NeoScan systems in Brazil? And how about service? And then there's, you show bone, teeth, and insects. What about other biological samples?
Yeah, okay, so maybe let's start with the first one. We don't have any systems in Brazil installed yet because we are a startup company. We are founded in 2019. Yeah, so we're a quite new brand. Currently, all our systems are in Europe, India. We're growing, but we're only in this business or at NeoScan for 2.5 years. However, we do have decades of experience. So I did visit Brazil several times for MicroCT trainings at other installations. So, and also the founder of our company has decades of experience with designing of MicroCT. Now, of course, this means being a startup company, indeed, we're new and a new brand has to be established and also a new network. And it is for this reason that we're happy to collaborate with DP Union, the partner who invited you for this webinar, and they will be trained or to do the local servicing of the instruments. Okay. And then the second question was about the applications. Yeah. So the question was, if I'm not mistaken, what about other biological samples? Correct?
Yes, correct.
Okay. Yeah, good. So when it comes to biological samples, there is a huge variety of what you can put inside the scanner. Basically, when you can put it in, you can scan it. So I have, in the past 2 years, I scanned a wide variety of worms, insects, zebrafish, yeah, whatever you can think of. So I only made a small selection. But with MicroCT, the nice thing about MicroCT is that it's widely applicable. So it can really apply to a wide variety of samples. And that's also what makes my job very interesting, because I get to work with biological samples one day, with food samples the next, and then in 2 weeks I'll be talking about geology. So it keeps my life fun as well. Okay. Other questions?
That's all the questions for now, but I did type some comments, just some little things that the service will be provided by DP Union. And then the free software we use is the Dragonfly software. I don't know if that was said or not, but I just wanted to put that out there. Christopher, in the software, there are some functions for gray shades / density and grain size measure. I mean for geological applications, as in the mineral 3D from Zeiss. Something.
Yes.
So
the 3D mineralogy analysis, again, this is about the analysis of the data. For that, we would reach out to third-party products. And I think many Zeiss users also use Dragonfly or even the Dragonfly Pro licenses. So Zeiss users who already have Dragonfly, so people who already have a Zeiss system are probably familiar with Dragonfly as well. And then that would be all compatible with our NeoScan data.
Perfect. Okay. Do we have anything else?
Oh, can I invite the group to ask something in Portuguese? I can translate if necessary, okay? Bom dia a todos, aqui é o André Sanches, da DP Union. Queria convidá-los a fazer mais perguntas. Se vocês tiverem algo que vocês queiram perguntar aqui em português, eu posso fazer a tradução também. Fiquem à vontade, tá ok?
Thank you, Andre.
So, okay, Evie, looks, yeah, it's done. Thank you very much for explanation and presentation. Thank you, Kelly, as well. Very good to know more about the technique and especially about the equipment, okay?
Mm-hmm. Well, and please make sure that whatever questions the people have, even in Portuguese, just send an email in Portuguese, preferably through you, and we can answer any questions afterwards as well. Okay.
Perfect. All right. Well, if we don't have any more questions, thank you guys all for coming and listening to Evie and having us introduce our company to you guys. Like Evie and Andre said, if you have any questions, please email Andre or at NeoScan at sorry, I can't speak today. Or you can email Evie directly. She had her email on the presentation, and then I can put my email as well in the comment section if you would like to email me. If you don't have any more questions, I think we're good to go.
Okay, good. Well, then I wish everyone a pleasant day.
Okay.